Now that we have an understanding of the key concepts, we're ready to do some calculations. And we'll begin in a setting called counting probability. So counting probability is a very simple setting where all outcomes of an experiment are equally likely. And when this is the case, calculating probabilities just reduces to counting the number of outcomes you're interested in and dividing by the total number of outcomes. Just as a quick example, let's consider the probability that I roll an odd number in one dice roll. Hopefully you can quickly say that this is 1/2. But just to get us used to the formalities that we'll be using, let's define the event that I roll an odd number to be A. This is equal to 1, 3, or 5, these three outcomes. And then we can do the calculation just by counting. So there are 3 outcomes in the event of interest. There are 6 outcomes total. 3 divided by 6 is 1/2. So this one, not too bad. As we go on though, when we have experiments that have multiple stages, these questions become a little bit trickier. And specifically, the tricky part is often counting the total number of outcomes in our sample space. Let's take, for example, the probability of getting first 3 heads and then 2 tails when I toss 5 coins. So this experiment is tossing 5 coins again. Well, this is the event of interest now. A is equal to heads, 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 tails, and tails. And the probability of A is going to be equal to 1 because I'm only interested in one outcome. But I need the number of total outcomes in order to get the probability. And in order to do this, one way I could think about counting is just listing everything out. So I could start with the outcome of heads, 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 and then heads, 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 tails. But because I already know the number of outcomes, I know that this is going to be quite tedious. Luckily, there's a different way. Whenever we have an experiment that progresses in stages, a way to count the total number of outcomes is just by multiplying across the stages. So the number of different options for the first trial times the number for the second trial, etc. And we'll see how that works here in the coin flip example. So again, I need the number of total outcomes, and this can be broken up into 5 different stages, one for each coin flip. Now for each stage I have only 2 options, either heads or tails. And so I can multiply 2 times 2 times 2 times 2 times 2 5 times to get 2 to the 5th, or 32. This gives me the denominator for my fraction, and so I have that the total number of outcomes is 1 out of 32. Let's see another application of this multiplication rule for counting the total number of outcomes. Now we'll ask how many possible outcomes for the experiment of pulling 2 cards from a deck. And the first one's pretty easy. There are 52 cards in a deck, and so I can pull one of any 52 in the first stage. The second stage is pulling the second card, and now we just have to remember that there's 1 card that's gone, and so I only have 51 outcomes left. And so if I want to know the total number of outcomes, then I can just multiply 52 by 51 to get 2,652. And I can use this now in calculating probabilities. For example, the probability of getting an ace of hearts and then an ace of spades is 1 out of 2,652, and I hope you weren't betting on that. These have been just a couple of examples of counting the number of outcomes in an experiment, which is sometimes the hardest part.